And then Wednesday we'll get into the unit circle, which you kind of talked about, but not really. Okay? So first things first, a radian. So there's two ways to measure angles. You're very comfortable with degrees. You've talked about radians at least in one of your math classes, if not two. Okay? A radian is a measure of an angle that intercepts the arc. Okay? And when our arc length S is equal to our radius R, then that is one radian. Okay. Now, it hasn't been very often that you've seen one radian, right? Most of your radian measures, if you remember back to last year, involved what number with it? Pi, okay? Now, 1 and pi are not the same number. Okay. If you could help me remember, how many degrees is pi radians? Thank you. Okay, 180 degrees is the same as pi radians. So we are going to use that fact to help us convert radians to degrees or vice versa. Did everybody get what they needed from over here? You can write what you need to. Okay. Did you get me in it too? I didn't want to be in it. Okay. Now, don't write this down, what I write in green. Okay, but I want to tell you why pi equals 180 degrees. Okay? S is arc length. It's a piece of the circle's what? What do we call this if we measure all the way around? Circumference, okay? So, here I have a circle, and how do we find circumference? 2 pi r, right? So if our angle equals our radius, or our arc length over radius, right? Arc length over radius. Well, if an entire circle has a circumference of 2 pi r, well, then that must mean that theta is 2 pi. So 360 degrees is the same as 2 pi radians. So 180 degrees is the same as pi radians. Okay, that's why we use it. Okay? So let's practice real quick. If we have a measure of, I don't know, let's say 7 pi over 9. I want to write it down. How do I change that to degrees?
185.
Okay, so we want degrees, and we want the radians to go away. Now, we don't write radians, but we can imagine radians here, radians here. What's nice is the pi's cancel, and we have 7 times 180 divided by 9. Okay, let's be a little bit smart about this. What's 180 divided by 9? 20. So really we have 20 times 7. Let's talk about going the other way. What if we had a degree measure? We'll just say 200 degrees. Okay. Now we're going to multiply by pi over 180 degrees. We want our degrees to cancel. And now we have 200 pi over 180. Now, you're not going to leave it like that. We would need to reduce it down. what does 200 over 180 reduce down to? What? Okay.
10 pi over 9.
Okay. It is important when you have a degree measurement that I see the degree symbol, and when it's radians, there's no label. Now, yes, a lot of times our radians will have a pi in it, but that doesn't mean it's a radian measure. I could have 10/9 radians. This is 10 pi over 9 radians, but just be careful. If there's a degree symbol, it's degrees. If there's not, then we assume radians. Now, there are some special angles that I know, especially if you were in honors algebra 2, that your teachers hammered a lot in terms of, do you know how to convert these? So I'm going to give you a circle. Okay. On Wednesday, we'll call it the unit circle, but we're not quite there yet. I want you, first of all, look at that first quadrant. How many of those can you change to radians just without even doing the math? Who remembers? What's 30 degrees? Uh-huh. What's 45 degrees? Pi over 4. What's 60 degrees? Pi over 3. Okay, do you remember those fractions? Okay, so what I want you to do, and how about we divide and conquer here? At your table, maybe divide up into the different quadrants. Like I'll take quadrant 2, I'll take quadrant 3, I'll take quadrant 4, I'll take these angles that are on the x and y axis. Divide up which angles you're going to find, and I'm going to give you 2 minutes to get all of these converted to radians. Okay, 1, 2, 3, go. You know all the answers?
Well, we already know.
Once you find your 3 or 4 angles, share with your group so that they can write them on their sheet as well.
Yeah. Oh, see. Then the 4 is one.
Yeah. Okay.
Pi over 4.
Zero's too pi because it's full.
You have a smile on your face, so that's good. Inside your eyes. especially in the dry patches of winter.
Okay, so for 120, I got 2
Okay, share with each other, and we'll go ahead and mark this up here.
Oh, it's just one
We
more.
already have half the circle. Well, like I said, I don't
Bring the same clock.
I can get that.
Yeah.
Alright, yours match mine?
They will now.
They will now. Are these conversions familiar to you? Okay, I'm hoping that they are. Especially those of you who came from Algebra 3, you are very familiar with these. Which one are you? 240 is 4 pi over 3.
It's 2 to 7, is that
7 pi over 6. 210 is 7 pi over 6. Yeah. We will come back to these numbers on Wednesday when we talk about the unit circle. But I want you to start being familiar with them, all right? Because they will be a big part of your life for the rest of your mathematical career. Okay, I'm just going to throw that out there. Okay. What I want you to do is I want you to keep this half piece of paper somewhere safe. Do you see how I have this marked with red and blue and green? We'll do that on Wednesday to your piece of paper and talk about all of the patterns and what happens. But just keep that somewhere safe so we can come back to it on Wednesday. All right? Can we do that? Okay. Let's get back. I'm going to go and erase this so second hour they don't see it. Okay. Let's get back to this. What I want you to do, well, actually, you have that piece of paper. Well, we just kind of talked about these, right? When we graph an angle in standard position, if you recall, we are always going to begin here at the positive x-axis, and then we are going to rotate, which way? Counterclockwise. Okay, counterclockwise, always in math. All right. We just talked about the angle measurements at the x and y axis, right? We have 0, 90, 180, 270, all the way to 360. If we're in radians, we have 0, pi over 2, pi, 3 pi over 2, all the way to 2 pi. Okay? So if I ask you to graph an angle in standard position, we need to think about how we would rotate through the quadrants. Okay? So the first one we're going to do some degree measurements first. So if I ask you to graph the angle 120 degrees, okay? Now I know we just looked at it, but what I want you to think about, okay, what quadrant would it fall in if those are our quadrantal angles? It's going to fall in the second quadrant because it's more than 90, but not quite 180. So when I ask you to graph an angle in standard position, you're going to have your x and y axis. You are going to begin on the positive x-axis. You'll rotate however many degrees, and you're going to tell me the direction that you rotate. See how I make like that arced arrow to show that I rotated that particular way? Now, if I ask you to graph negative 750 degrees, yikes. Okay. This might be more than one time around, right? Negative 750, which direction are we going to have to rotate? We're going to have to go clockwise because we want a negative angle, all right? So if I go all the way around clockwise, I am now at negative 360 degrees, right? What if I go another time around? I'm at 720. So now I just need to rotate 30 more degrees in order to get my angle. So I rotated twice around to get to negative 720, and then 30 more degrees to get to negative 750. So you can see by this little spiral, right, that we went around twice plus a little bit more. Okay. When we graph radian measurements, you're really going to need to think about fractions. Okay? If everything is in terms of pi, it is okay to take off that pi and think about the fraction without it if it helps you. Okay? If we start at the positive x-axis, one time all the way around is 2 pi, correct? Let me ask you this. Is 5 halves more than 2? It is, right? 5 halves is 2 and a half. Do you agree? So if we are going to graph this, we need to go all the way around to 2 pi, and then we have 1/2 pi more to go. Well, 1/2 pi is the same thing as 90 degrees. So all the way around is 2 pi, and 1/2 pi more to get to 5 halves would be that same as 90 degrees. Okay, 4 pi over 3. Okay, I know that was one of our angles on the circle. Okay, now, is 4/3 bigger than 2? No, it's smaller than 2, but is it bigger than 1? Okay, 4/3 is bigger than 1, but it's still smaller than 1.5, right? So here's pi, here's 3 pi over 2. 4/3 would be in between those two. 4/3 is bigger than 1, but smaller than 3 halves. So we would need to graph this in the third quadrant. Okay? Like I said, you're going to be very, very familiar with that angle by the time, well, Friday rolls around. All right? Okay. But you graphed angles last year, so hopefully this is just a refresher for you. Okay? Another task that I hope is a refresher are, let's see. I want you to talk about these right here. What does it mean to be complementary, supplementary, and coterminal? You have 1 minute to come up with your definitions. Go.
It's in the same spot.
Or, because like the
What is called? Oh, yeah. Whatever. Oh, yeah. So if it's from
All right. What does it mean to be complementary? Brecken, what did your table talk about?
You said 90 degrees.
Okay, what is 90 degrees?
A right angle.
Okay, so when we talk about complementary, how many angles are we talking about? Are we talking about one angle or are we talking about two angles?
Two. I don't know.
Consult with your table real quick. Are we talking about one angles or two angles? Did you come up with what was the decision?
No.
No?
One and she said two.
Okay, we're at kind of a crossroads here at Pod 5. Who can help them out? Are we talking about one angle or are we talking about two angles? Okay, we're talking about the sum of two angles, all right? Oh, those moved on me. There we go. The sum of two angles is going to be 90 degrees, or if we're in radians, pi over 2. Okay? Caden, what about supplementary?
Sum of two angles to 180 degrees.
Okay. Or if we're in radians, we're talking about pi. Okay? I know that you can do this in degrees. Okay? What I'm most concerned is, can you do it in radians? So we are going to find the complement and the supplement of 5 pi over 12. All right, so if we have 5 pi over 12 and I want the complement, then I want to know what angle adds to 5 pi over 12 to get pi over 2. So to find the complement, we need to take our pi over 2 and subtract 5 pi over 12. Okay, we are working with fractions. It may be helpful to have common denominators. So if I create a common denominator, this would be 6 pi over 12 minus 5 pi over 12. So our complement would be pi over 12. Our supplement, two angles that add up to be 180 degrees or pi. So if I have an angle and I want its supplement, we're going to talk about the difference between pi and that angle. Okay. Here again, if we're in radians, we're probably working with fractions. So make a common denominator so you can see that our supplement is 7 pi over 12. My hope is that you can do this without a calculator, okay? All right, let's talk about that third word. Coterminal angles. This is probably the one that was the least familiar to you, okay? Ryan, what did you talk about there back in Pod 5? Okay. You weren't really sure. What does co mean? Typically in a word? They share? Okay. Co usually means share, right? Like co-teacher, two teachers are together. Co-worker, two people who work together, right? Co-captain, you have two captains. So co-terminal, Caden, you wanted to take a shot at it?
Are they like two angles that share the same place on the graph that are apart by like plus or minus 360 degrees?
Yes. Angles that share a terminal side So if they're sharing a terminal side, yes, they're going to be different by plus or minus 360 degrees or 2 pi. Okay? I like that you explained it that way. Are you okay with my shorthand for angle? Like we've seen that before, right? So if we have an angle that shares a terminal side, like Kaden described, we can either go around the circle 360 degrees forwards or backwards, which is why he said minus. So let's think about an angle of 70 degrees. Okay? If I were to graph 70 degrees, which quadrant would it fall in? It would fall in quadrant 1. Okay? Well, if I take that and I rotate another time around the circle, okay, that angle that I just drew in red has the same terminal side. So if we take 70 degrees and we add 360 degrees, then 430 degrees is a coterminal angle. If I take 70 degrees and I add 360 twice, then we're at 790 degrees. That's also a coterminal angle. If we go around again and again, we can be really obnoxious, right? Okay. We also could take this and go the other way, like in green. That angle shares a terminal side. So we could take 70 degrees and subtract 360 to get an angle of negative 290 degrees. Okay, and we could keep going and going and going. Okay, now please don't be obnoxious when I give you a quiz. Okay, if I ask you for a coterminal angle that's positive, you know, add 360, and if you get a positive angle, awesome, you can stop there. You don't need to like add 360 times 15 to get me an angle. If we're not going to do this one because we're kind of running short on time, if we were to do this, we would add and subtract what measure? 2 pi. If it's in radians, use 2 pi. There again, you're probably going to want some common denominators in order to be able to find your answer. Okay? We're going to write down 2 formulas to finish our time together. One is for arc length, and one is for area of a sector. Now, let's come back to this. Who can tell me, who can describe what a sector is? It looks like what?
Section.
A section of a?
Circle.
A circle. A section of a circle. Sometimes you consume it. What do we consume that looks like a section of a circle? A pizza or a pie. Okay, so we're talking about a pie slice or a pizza slice. Okay, so here we go. What I want you to do is arc length. Write down the formula. This only works if theta is in radians. Arc length S describes the length of a piece of circumference. It's basically the rearrangement of the radian formula we wrote down in the very beginning. So arc length is measuring a piece of circumference, and we find it by taking theta times r, where theta is in radians. So if you are given a degree measure, that degree measurement needs to be converted before you use this formula. r squared. Did you all write that theta has to be in radians? Okay. Since we took this from the radian formula and just rearranged the letters, the only way it's going to work is if you're in radians. Okay? And then if we're talking about the area of a sector, okay, so like this yellow pie slice, if we want the area of a sector, then we need this formula, which once again, theta needs to be measured in radians. See you tomorrow.
So that's supposed to have two eyes.
Radii. That's the plural for radius. Kind of like cacti. Which somebody told me that the plural for cactus could be either one. But I'm not really sure about that. I always say cacti. Or maybe it was hypotenuse. You could say hypotenuses or both sound strange. Okay, so you've seen these formulas before. If you need an example of them, stop by after school and I can go through a problem with you. You have book work for tonight, so make sure you have your book. If your online book isn't working, I have more books to check out because I had some people who dropped this class at semester. So if you need a book, let me know. Same routine. I'll walk around tomorrow and check off your homework while you do a warm-up problem. Okay, that's not going to change. My expectations for you to do homework are the same. I think it's important. I think you should do it. Something that I hope you thought about when you filled out kind of your goals. Are you putting the right amount of effort into your homework? Are you doing it to get it done, or are you thinking about it and putting that hard work in? All right. Good to see you back.
It changed.
Is that a good thing or a bad thing?
Oh, I think it's right across the hall in this.
I don't know.
What are you looking for?
Miss Baker's classroom, because she said that we're